You can never be too safe. So it is in life, and so it is with your data. Online crooks are finding ways to tap into streams of data to steal personal information, passwords, or something worse. These attacks are called harvest-now-decrypt-later, and it allows thieves to record data in transit to later decode for all the valuables. There is a way to stop it, but it takes more than some antivirus software. CyberRidge is a photonic encryption technology and security startup. Its flagship product is a plug-and-play photonic layer transmission system that integrates with existing fiber to transform your data into encrypted noise as it moves along to its destination. That way, instead of getting vital information, would-be thieves are left with this. Dan Sadot is the founder of CyberRidge. In this episode of All Things Photonics, we'll discuss the crimes driving demand for this tech, the groups likely to use it, and the finer points of post-quantum optical security for data in transit. That's next.
Today's episode is brought to you by Hamamatsu Corporation, a leading manufacturer of devices for the generation and measurement of infrared, visible, UV light, and X-rays. Hamamatsu is dedicated to the advancement of photonics through extensive research and offers specialized systems for select applications. Visit hamamatsu.com to learn more.
From Photonics Media, this is All Things Photonics, a podcast where we explore industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, we'll speak with some of the brightest minds in industry and research about the trends shaping the landscape of photonics.
Joining me right now is Dan Sadot, professor, founder, and CEO of CyberRidge. Now, before I get into photonic encryption and post-quantum optical security for data in transit, I want to set the stage by asking, why are current cybersecurity measures maybe falling short?
Okay, so hi, nice to meet you. So jumping directly to your question, by now, all the cybersecurity technologies and efforts are all around encrypting the data in a digital manner. Nothing is preventing from harvesting the information when it's being transmitted. Harvesting, recording, and once it is there at the adversary hands, you never know what kind of tools or what kind of means you will have in order to break it at some point in time. So there is no time constraint, and there is no technology advancement constraint that will prevent the deciphering of the data at one point in time. So that's one of the most troubling status right now as per today.
Interesting. And CyberRidge's flagship product is the plug-and-play photonic layer transmission system. Talk to me about how this works and how it interacts with optical fiber.
Okay, so that's exactly right. This is kind of a plug-and-play solution, but maybe I'll just start by saying that this is exactly solving this kind of, I'd say, harvesting gap. That is the one that I just mentioned a moment ago. All the other, I would say, protection schemes, they are recordable. And our plug-and-play solution, the moment you use that, it will prevent any adversary from putting his hands on the data, either by tapping the fiber, by putting a receiver at some point along the line, and so on. So that's the most important benefit. It's kind of adding a photonic shield that protects the data in the most basic level, in the optical level, because in any case, the data is being transmitted optically. In our case, we take advantage of the fact that the signal is optical, and the fact that most of the expertise in our company, in our team, is around optical communications and optical manipulations. So we just take the same building blocks, like the transmitter, the laser, the modulator, and so on, but we build it in a very non-natural way. We utilize it in a very non-natural way. So the outcome of the transmission that is done by CyberRidge is actually the opposite of the normal way of transmitting data. Usually you want to transmit the data at a very high quality. You see pronounced bits in the optical domain. Even though the bits are encrypted, they are observed and therefore they can be recorded and later on can be deciphered. In the CyberRidge solution, the transmission turns the signal into optical noise. So basically what you see in the fiber is just random light that doesn't represent anything. It's useless. The only chance to extract or to recompose the signal, the information, is by rebuilding the signal in the optical domain, and that's exactly what the CyberRidge product is doing, is destroying it, so to speak, at the transmit side and recomposing it all optically at the receive side.
Interesting, and we can understand why governments or businesses or really anyone would want to protect their data. This is sensitive information. And I want to mention, investors backing CyberRidge are very excited about this, and they mentioned that the world is racing towards quantum threats. How present are these quantum threats right now, and how problematic can they be?
Okay, this is a very relevant question. I can share with you that once the company was started 3.5 years ago, this question was very relevant. And the main answer at that time was that not necessarily you need to break the code by quantum computers, but you can put at some point in time your hands on the key. And that's what's kind of going around the, I'll say, quantification of how big is the threat, exactly your question. But I can tell you very clearly that by today, like 3.5 years later, all the governmental, all the tier one financial entities, they are all fully engaged with being prepared for the post-quantum era. They call it like the Q day. The most, I would say, common projections are that by 2029, 2030, there will be already quantum computers available for public. And at that point in time, you never know how long your data will be kept secure. So it is very, very relevant and very, very active in order to prepare for that day.
Yeah, and you mentioned, the quantum era is, upon us. It's right around the corner. So what does it mean to be post-quantum ready?
Okay, so generally speaking, it means that even the day the quantum computer arrives, you will be prepared in the sense that your data will keep on being protected. That's like the most of the basic way to define that. Now, how to do that? That's a great question. So in one hand, people are trying to just generate or invent new encryption codes that will not be deciphered by quantum computer. But of course, you can never prove that. You never could have proven mathematical resilience. What we are proposing is as I already mentioned, it's kind of a game changer. The way we're transmitting the data, you don't see a signal. Once there is no signal, there are no bits, it means that literally there is no raw material, raw data for a quantum computer. So even if you have a quantum computer today, it will be useless. I mean, keep in mind, like kind of a slogan: no data, nothing to hack, right? So with CyberRidge, there is no data, so there is nothing to hack. Doesn't matter how strong your quantum computer or any computer power is. There's no input into this engine.
Gotcha. So you're taking this data in transit. It's encrypted, so anyone trying to sneak in and get it is getting nothing but noise.
Mhm.
And then on the other end, the person who is transmitting that, they have the photonic key to kind of unlock this. How does that work to take this noise and then turn it back into the original data?
Okay, so I'll now deep dive a little bit more into the physical layer or photonic layer. So basically, in a normal transmission, optical transmission way, you take a light source, which is usually a laser, a very high quality light source, and you modulate it with the information. In terms of the signal, both in the time domain and in the spectral domain, they are very pronounced. You see in the time domain, you see the bits, you see like high power, low power, or stuff like that. In the spectral domain, you see very clear pattern of the signal, like the laser pattern, which is modulated. With CyberRidge, so what we're doing 3 optical manipulation steps that are changing totally the paradigm of transmission. We're doing just the opposite. Instead of pronouncing the signal, at the first step, we're spreading it dramatically or very aggressively in the spectral domain. We're using very special lasers that are not designed for transmission of communication. They are designed for satellite synchronization or for sensing of very, I would say, unique signals. These are very short pulse lasers, like a fraction of a second, could be like 10 to the minus 12 of a second, like femtosecond. And the reason we're doing that is because the shorter the pulses are, the wider the spectrum is in the frequency domain. So this allows us to take the information and spread it very aggressively. And the purpose of doing that is that it will be much, much broader than any material or any detector in the world will be ever capable of recording, like multi-terahertz of analog spectrum. And there is no material on Earth that can respond that fast in order to capture the whole spectrum. So that's step number one. Once the information is spread and for sure cannot be captured at once, then we kind of destroy the correlation between the different parts of the spectrum. In an optical language, it is called decoherence. So instead, the laser, to begin with, is a very coherent light source, and then we are making it decoherent or uncorrelated. And the reason for doing that is that if somebody is putting his hand on a portion of the spectrum, it will be useless because it will be totally irrelevant to another portion and to the other neighboring portion and so on. So either you can hook all the spectrum all together and it's not possible, or you just keep hooking portions of that, but they are unrelated to each other. This is, by the way, what we call the optical key, the way of uncorrelating the data. And the last, so to speak, the last nail in the coffin, we're taking this whole chunk of optical signal and attenuating it very aggressively, so it will be very weak. And then we bury it literally below optical noise, real noise generated by real random sources like optical amplifiers. So there is a spontaneous transmission there, spontaneous emission. It's called ASE, amplified spontaneous emission. So once you measure the power of the signal, you just measure the noise, and the signal is much, much lower and below the noise. So at this point, like information theory will prove that this signal is useless. There is no chance to extract any information while the signal is so much weak and below the noise level. So now the only chance to recompose and reconstruct the signal is trying to rebuild the signal that has been spread so aggressively in the spectral domain, rebuilding it and getting it back to be stronger than the noise. In order to do that, you must have two things. You must have the CyberRidge equipment that is being able to collect those slices of the spectrum. But before that, you must turn those elements, those different slices, to be coherent again, to be correlated again, because once you collect them, you want to collect them in a coherent manner. So therefore, that leads to the necessity to have the key, the optical key, at the receive side. You must have the same key that has been used at the transmit side, and it must be before the signal arrives, because once the signal arrives, you already have to be prepared to apply the key, which is basically optical manipulation. And light is arriving at the speed of light, so you don't have time to do anything. Either the light goes through the right key or it's game over. So, and once you do have the key, so the signal is back to be coherent, and then you can collect it. And just to summarize the final effect, the signal is being collected in a coherent manner. So it's kind of a coherent addition of the different portion of the signal, while the noise that is also there, it did not disappear, but it's still there, but the noise is certainly not coherent. It's kind of random noise, so it's being collected in an incoherent manner. So now, those who are familiar with optical laws, so a coherent addition of optical signal is following a square law detection. So if you collect, for example, 100 elements in a coherent manner, you'll get 100 to the square, like 10,000 times stronger signal, while the noise will be collected in a linear manner, so it will be only 100 times stronger. So this is basically the optical mechanism, like an inherent optical gain mechanism that will enhance the signal again above the noise. Once you do that, and this is again, just to emphasize, it's all optical manipulations, that's the point where the signal is back to normal, and then you can record it, and then the receiver can receive the normal signal at high quality, back to normal again. So just to summarize, all those manipulations, those three steps that I mentioned, the spectral spreading, then the key applying the phase mask that is changing the or decorrelating the signal, and then the attenuating of the signal below the optical noise. All those steps are all optical, real-time manipulations, and the same steps are happening at the opposite manner at the receive side. And for that, you must have optical tools and real-time tools. So in terms of battlefield, we moved the battlefield from the digital domain to the optical domain, and you must use new weapons from scratch. All the cyber attack weapons of digital domain are obsolete, and there is no offline, I would say, luxury whatsoever. You must do everything under the gun in real time. No second chance. Either you know what to do or it's game over. I hope it's explaining the idea intuitively.
No, yes, that was very helpful to grasp that, and you mentioned battlefield too. I can imagine applications in defense where there's critical information that you don't want to see get passed through. But I mean, there's really so many different kind of potential clients, I guess, that would be interested in saying we need to protect our data, whether it's business secrets, it's defense. So who without revealing too much, are the kind of clients or people that you expect to see showing the most interest in this kind of technology to protect their data in transit?
Yeah, and that's a very good question. And naturally, first idea would pop to your mind is all the DoD related entities, which is natural, and also all governmental entities. But I'll say a much more general statement. Every entity on Earth that has sensitive data should be concerned about the Q day, about the post-quantum day, and certainly should be interested in such kind of solution that will protect the data. I can share with you that we are actively interacting with DoD and governmental entities all over the world, but at the same time, also with purely commercial entities like banks, like credit card entities, like healthcare enterprises. And again, all those guys that do have sensitive data, especially if it's data that will be also sensitive in the future. Because if you have data that you need to protect only now, so now today there are no quantum computers, so you're fine. But if you have information that you must make sure that it's also being protected a couple of years from now, or maybe even 10 years from now, for example, if you take DNA information, it will be for generations from now. So you must make sure that even today it is not being harvested. And that's exactly what we're offering.
Yeah, I feel like constantly you get an email from Google or something that'll be like, "Hey, your information may have been in a breach." You just hear about that so often that it's almost desensitized to it. But there's real serious impacts to some of those. And going back to the quantum era, it's coming. It's not here yet, but we can feel it.
Mhm.
Quantum computers we keep hearing about them being scalable, and when we get there. So let me ask, what are the barriers, though, from now until then to adopting this system, and how are you and your team kind of working to address those?
Okay, so this is also a kind of a nice situation for us because even though we are post-quantum, and quantum is a kind of a technology that is being still in, I would say, development, our solution is based on existing technology. I mean, as I mentioned, I mean, we are not doing anything quantum, but we are preventing from quantum computers to have even the chance to manipulate the signal because they don't have the input. So the nice thing is that we are based on per today technology, not future technology. Our system, our product is based on almost off the shelf elements. They are all used in a very different way and even in a very non-natural way, but the elements are there. Most of them are off the shelf. We're just rebuilding it and doing uh, um, system integration, which is very, very unique. So jumping to the end, we do have the product running today. It is being already deployed in some operational networks today, and it's in a sense, it's really kind of a plug and play. It's so to speak, it's a communication box that you put and replace the existing optical transmitter with the CyberRidge transmitter. You hook it with a normal interface, like a 100 gigabit Ethernet interface, to any commercial router or a server. and once it, which is standard digital data that is running into our system, we do the conversion from digital to optical, but in the very different way that I was explaining. And from that, it goes into existing optical fibers that are already deployed. So in terms of adopting the technology with our approach, it is pretty easy. It is more like I would say, psychological barrier to adopt a technology that is post-quantum ready and so on. And it takes time to convince that this technology does work. And I admit it is not trivial to convince that it does work, because we're doing very non-natural way of transmission and so on. But once this is being proven, and it is being proven as we speak around the world with multiple POCs in Europe, in Asia, in the US. So once we prove that it does work, the adoption is more on the decision level and not on the technology level. There's no real technology barrier there.
Mm. And you mentioned some of your systems are already, in play, in operation. So what are kind of the key points on CyberRidge's roadmap or timeline? And what is the future of photonic encryption?
Okay, so maybe I'll start with the second half of your answer. So the future, the way I see it and how I hope it will happen, is that this will be kind of a standard of way of protecting data, complementary to all the standards that are out there. I mean, we're not competing with the conventional digital encryption. It's kind of an additional layer, an extra photonic shield, so to speak. And in my vision, this should be part of an alternative standard for extra protection in the photonic layer. So this is a clear target for us to be approved as a standard, to adopted as a standard. In terms of the roadmap, so right now we have standalone systems that are doing all the functionality. So naturally, it is more for the high end and the high rates and so on. But the more it is being adopted and the more it's being mass productive, we can turn it to be much more, I would say, low cost, compact, integrated. Now there's a lot of activities going on, turning the optical solutions in general to be silicon photonic based. So it's basically turning to the chip level, and nothing is preventing our solution to be part of this integration. So we can be another chip in the chain of a chipset that will be part of any mass productive solution inside data centers, outside data centers. So it can be all over the place. So that's the roadmap, to make it more and more compact, integrable, and of course low cost. So and actually those are the steps we're following now.
That's great. Dan Sadot, thank you so much for joining us and talking about photonic encryption and CyberRidge's role in this big technology as the quantum era looms.
Okay, it was my pleasure. Thank you very much as well.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.